All right, 5130, Math 5130, by the way. Um, I think it's only fair that I demonstrate how to find these results using StatCrunch. So if I'm going to run the descriptives, the mean and standard deviation, that's one place where I think, well, there are many places actually, let me grab these. Um, Sorry, I'm not talented enough to speak and uh, click. I think this is one place where StatCrunch is a lot easier than R. No coding, just drag and select and so on. So mean and standard deviations are reported right there. Immediately go in, let the reader know what the research question is that we're addressing. Uh, Full sample 43, easy to get. And again, no concern as I went into more detail in the previous video. We need 15 cases per predictor. Now we have two predictors, so 15 times 2 is 30, less than our sample size of 43, so no concern with that. Next thing we do is we dive into our assumptions, and just like in R, we have to create our model first so we can create our residuals. So I want to predict SSQ from age and HFSCI. And then I need to be careful with what I select down here. So first of all, I want to select the test of hypothesis. I want the Durbin-Watson test. I want the residuals versus predicted test, and I want to save my residuals so I can use those in a Shapiro. And yeah, I think that's it. So I run this. I'm going to circle back to this a little bit later, but while I'm here, I'm going to grab this plot, copy and paste it, and you can see I paste it right there. Now, let's go through this piece by piece. The Shapiro test, again, I think it's kind of goofy the way we have to do that in R, or in StatCrunch, but we go to tstat, one sample with data, pop our residuals in, and then come down here and do the Shapiro-Wilk test on the normality test on our residuals. This up here for this test is completely irrelevant. So you can see that the Shapiro test 0.92, we are significant at the 0.01 level, so a slight concern. Next thing I'd want to do is look at the QQ plot. It's kind of cool the way they do this. Just come to graph and go to QQ plot and pop the residuals in there and go for it. And I copy and pasted that here. You're going to expect some deviation away from the line, but you don't want a lot of deviation away from the line, which you have right here. But nevertheless, I don't see enough deviation for concern. Next thing we get into the independence assumption with the Durbin-Watson. We'll get that in just a second. And unfortunately, there's no way to do VIF factors in StatCrunch, at least that I can find. So you'd probably need to either run those in R or, unfortunately, not be able to include that statement unless you can find a way to calculate those. So let's run our model, which I've already done. Or let's just access it. So multiple regression 4. Alrighty, and let's go back and take a look at the model. So the Durbin-Watson statistic, it doesn't give a p-value in StatCrunch, but it gives 2.17. You're not going to remember this. I don't, but there's a standard for Durbin-Watson. It'll always be between, I think, 1 and 4, and anything around 2 is no concern. But you can Google that and get the cutoffs and thresholds for concerns with low, high, or no concerns at all. So in this case, we would just report it, and I do know the 2.18 is no concern. So next thing I would do is I'd go into the table up here. And the first thing I talk about is the model diagnostic. I get that right here. So degree of freedom 2, 40, which I've reported. Test statistic is 29.25. Statistically significant at the 0.001 level. So we indicate that as a set, age and HFSCI reliably predict SSQ. Now we look at our coefficient table and we can see that the only one that's statistically significant, the only predictor, is HFSCI. So I tell the reader that. And I say this set of predictors in combination contributed 57.4%, which is the adjusted R squared, which is reported right there. Again, we always use the adjusted R squared when we have multiple predictors. If we have only one predictor, we use R squared. In fact, in StatCrunch, this won't even be given, I don't think, for one predictor. Okay, so we would want to, I would report for HFSI because it emerged statistically significant, so the test statistic is 7.53, and we are significant at the 0.001 level. Now, this table with StatCrunch, I think everything is pretty easy to determine. These three numbers right here come directly from the table of the parameter estimates right up here. Age the same way, and this predictor the same way. I'll show you how to get the confidence intervals in just a second. I've already calculated the means and standard deviations for you. Adjusted R squared, model diagnostic, which we just reported previously. So really the only thing in this table I need to show you is how to get the 95% confidence intervals and how to do the correlation analysis up here. Well, it's really easy to do the correlate or the confidence intervals because all I have to do is just come and click this button. And you can see that the confidence intervals that I've reported, 10.39, 73.65 are right there and so on. So that's easy to do. For the correlation, we go to summary stat correlation, and I want to add all of the predictors and the dependent variable. And I want a two-sided p-value. And so it gives me a correlation matrix. So the 0.13 you can see is SSQ and age, which I have reported right here. Now, right here you can see I put dashes because SSQ correlated with itself. It's actually 1, but it's irrelevant. Age correlated with itself is irrelevant, and age correlated with, HFSCI correlated with itself is useless. I don't need this lower triangle either, because if I want to get the correlation between age and SSQ, I can get it between SSQ and age. So really, I transfer this information into these 3 cells. Now you can tell if you had a lot of predictors, let's say you had 10 predictors, it'd be very clumsy. So to put this in a table, I would probably I'd probably put that in the narrative if we ran into something like that. So I think that takes care of everything. Unfortunately, again, the VIFs play an important role, but I can't find how to calculate VIF in StatCrunch. The good thing about it is it's really, really easy to do in R. Just create your model and install the package or access the library for CAR, C-A-R, and then just type VIF of your model and you'll get your VIF. So you should be able to add those. I wish I hadn't deleted those now because they're that easy to get. Anyway, that's the way we make these calculations using StatCrunch, if StatCrunch is the way you prefer. All right, take care.